of what happens here. So let's first try, for int. Let's show what modifiers. What can you do as in order to modify int? Okay. So modifiers for int. Okay. So let's say we just want to create some variable in C language, as we have presented before. So you could have your straightforward int x. Okay, it's a variable of type int. Okay, right here the way it is declared, C assumes that is 32-bit and it is signed. That's by default. Okay, that's the default when you only use the int without any modifier. So what if we use the modifier short? So we could say short int x, and in this case, when we use the short modifier, then we are only going to use 16-bit. Still, it is unsigned. Okay. So what is the range if you use 16 bits? What is the range of numbers you can represent signed? Okay, I leave you that for your for you to derive that. Okay. We can also use, for example, this is where we can define whether something is signed or unsigned. We can do signed int x, which has the effect that we described before. We're going to have and actually it's equivalent to use int. Okay, but in some cases, just for clarity, you include signed. Okay, so that again, when somebody else reads your code, they know what it was your intention when defining x. Okay. Then we also have signed int x, and it's the same as before. Okay, we can actually this is the way we declare something, so that we increase the range of integers, of positive integers that we can use. And the last one is long int x. Here long has the opposite effect of short. Okay, in this case, when we use the long modifier, then we're going to go to 64 bits. Okay. Now, what is more interesting here is that we can actually combine, for instance, unsigned short or long unsigned long. Okay, we can actually create a variable that is unsigned and that is short. Okay, so it's 16 bits again, but now it is unsigned. Okay, and so forth. So we can also combine modifiers. Another thing is that as far as signed and unsigned, okay, they can also be used for characters. Okay, to do unsigned or signed characters, as we discussed before. So this signed and unsigned. Okay, also is for cars. Okay, for signed and unsigned. This one. Okay. So there are in my previous slide, there are others. Okay, other modifiers like const and volatile. We'll discuss this in later on. Okay, so I'm just going to leave them like this, because they are special situations where you will try to use this. Okay, so let's see. Now we have basically for data objects, we said we had modifiers. Okay, we had modifiers. We also have something that is called specifiers for storage classes, or storage class specifiers. And this really specify different ways in which we want to store or variables. Okay. So remember, when we talk about storage, we talk about memory locations, right? Where do they go? And through the course, we're going to see why. Okay, where are these useful? Okay. Right now, it's important to say that we have a auto, okay, static, extern, something called register, and something called typedef. Okay. Let's not worry about register and typedef for now. Okay. It's more advanced topics that we'll discuss later in the class. So let's focus just on auto, static, and stern. Okay. Auto is the default. Okay. If you don't use a specifier, okay. So for instance, you could use auto int is equal to just saying int, or auto float is equal to just saying float. Okay. And basically, this is your more general type of declaration, where basically what you are doing when you use these storage specifiers is that basically you are telling the compiler that how you want your variable to be stored in memory. Okay. So basically, when you say auto, this implies that the variable is going to be stored as soon as possible, as the program enters the main function, or when you enter any function in C, you are going to create any variables that are declared within the function are going to be created instantly. So as soon as let's say the C program, okay, hits something like out int, then it's going to go to memory and it's going to reserve 4 bytes, okay, for it. And then then you can proceed to do whatever you want to do. But this means that basically it reserves memory right away. Okay. And again, but this is as soon as you have to wait for your program to run. Okay. So let me put here a disclaimer. Okay. Wait for program. I guess this is not very visual, right? Wait for program to run. So, yeah, sorry, the camera is kind of high. I'm using like one of those luggage chairs, or that I put over the desk, but it's kind of high. Okay. Anyways, so what about static? Okay. A static is it's used to create data objects, okay, before execution begins, okay. Static before execution. So if you see, kind of static is the opposite of auto, right? Auto, you have to wait for the program to run. A static is before you start execution. Basically, there is like a stage of initialization stage in which the microprocessor is going to run some, or the operating system is going to run some preliminary steps, and during those steps, you actually create you can create the static variables. Okay, and what happens with static variables is that if you are, for instance, calling a function like, remember, like my power or like factorial, then whatever functions you used internally for the function get destroyed right after the function gets executed. Okay. Then and again, this might sound confusing. We'll later on we'll go into more detail once we start actually writing C programs. Then the extern function is kind of interesting. Okay. And I just lost my